Imagine a classroom of sixth graders staring down a test full of high-difficulty math word problems. Pencils stop moving. Eraser shavings pile up. The students hit a collective, immovable brain freeze. Singapore math relies on what are called heuristics, specific, structured problem-solving strategies. The bottleneck happens right at the start. Students often look at a paragraph of text and find themselves unable to determine whether to draw a bar model or use the assumption method. Teachers face a constant deadlock. Giving a struggling student a tiny hint, like pointing to where a box should go on the page, often turns them into mindless scribes who copy without engaging their own logic. But holding back all help can cause an entire class to stall for an entire period. Teacher Kobayashi proposes a fix for this deadlock, deploying a highly specialized AI coach. Kobayashi's coach centers on the Socratic method, utilizing constant counter-questioning to guide the student toward their own logical conclusions. True learning requires a technological system that refuses to solve the problem. This shift in focus moves the exercise away from the correct final number and toward the metacognitive process of thinking about the problem. To build this system, we ground the AI in structured pedagogy. The first step involves feeding the official Singapore MOE primary mathematics syllabus, specifically the 11 core heuristics, directly into the AI's knowledge base. This diagram shows the MOE framework, dividing problem-solving into 4 cognitive branches: representation, calculated guess, processing, and changing the problem. The first branch prompts translating text into block models. The second includes difficult strategies like guess and check and suppositions. Uploading these specific categorized techniques strips away the AI's default identity as a general chatbot. Now it becomes a domain expert mathematical coach. We shape how the AI interacts using the PTCF framework: persona, task, context, and format. For the persona and task parameters, we instruct the system to act as a patient Ministry of Education tutor. Its objective is to guide students exclusively through Socratic questioning. The context parameter carries an unbreakable rule. The system must never provide the final numerical answer or the complete working. We then define the format. Step 1 is the probe. Before calculating, the AI must ask the student to identify the known parameters provided by the text and the ultimate goal of the question. Step 2 is the heuristic suggestion. The system selects 2 relevant strategies from the MOE framework and asks the student to evaluate which one would be more efficient for this specific problem. And step 3 is the micro-steps protocol. The AI provides tiny, incremental hints, much like slowly squeezing toothpaste, only when a student explicitly states that they are stuck. This restrictive PTCF framework overrides the AI's default conversational instincts, turning the system into a rigid scaffold for student metacognition. This diagram illustrates our stress test using a classic primary 6 problem. A farm has a mix of chickens and rabbits. There are 30 animals and 100 legs in total. Find the exact number of each. When a student asks for the answer, the AI refuses. Instead, it offers a choice. Should we use guess and check, or the method of suppositions by assuming all 30 animals are chickens? If the student stalls, the AI triggers the microsteps protocol. It asks, let's try the assumption method. If all 30 animals were chickens, how many legs would there be in total? The student calculates that 30 chickens would have 60 legs. The AI then points to the discrepancy. If those chickens only account for 60 legs, the student has to explain where the remaining 40 legs originated. The student realizes the extra legs belong to the rabbits. Since each rabbit adds 2 legs to the chicken count, dividing 40 by 2 means there are 20 rabbits and 10 chickens. They arrive at the solution entirely on their own. Developing AI in this manner provides a systematic scaffold for the thinking process, reclaiming valuable classroom time for teachers to facilitate deep, independent breakthroughs. We have seen how AI can turn a math crisis into a moment of clarity. Next time, we move to language learning in Episode 5, Operation Saving the Bananas, where we build a bilingual scaffold for writing. Like and subscribe to follow the journey.